Hi everyone, this is example 13 on unsteady flow. A rectangular reservoir 3 meters by 4 meters is positioned in the oceans such that its bottom, which is 5 meters below the seawater surface, is always horizontal. If a 100 mm diameter orifice on the bottom of the tank with coefficient of discharge 0.62 is opened, how long until the depth of the seawater surface in the tank rises 1 meter? What was the initial flow rate and how long until the seawater stops entering the tank? Assume constant seawater surface. So this is the situation. We have here seawater surface. We have here the tank, which is held in position such that the bottom is always horizontal and 5 meters below the seawater surface. Since this is seawater surface, the area is very large, so A is infinite. Then this is the area M, which is 3 by 4 in plan, so 12, 3 times 4 is 12 square meters. So for number 1, the how long until the depth of the seawater surface in the tank rises 1 meter. So only the seawater level will rise in the tank. The level of ocean water is constant because that's a sea water level. And therefore, the initial head is 5. When the depth of seawater in the tank is 1 meter, then the final head would be 4. So the formula is 2 ma 2 ma over ma kautog. So 2 ma quantity square root of hi minus square root of hf over quantity m plus a kautog. But in this situation here, a is very large, so a over m plus a. So for example, a is 10 million, and in fact it is more than 10 million. It may be trillion square meters over 1 trillion 12, so the a over m plus a would be 1. So the formula reduces to 2m quantity square root of hi minus square root of hf over kautog. So substituting values, 2 times 12 quantity square root of 5 minus square root of 4 over 0.62 pi 0.05 square root of 19.62. Radius of orifice is 50 mm or 0.05 meter. So the time is 262.7 seconds. What was the initial flow rate? Initial flow rate QI is kautog, where initial head is 5. So substitute 0.62 times pi 0.05 square times square root of 19.62 times 5. So the initial flow rate was 0.04823 cubic meter per second. And that is changing because the head changes. Then 13.3, how long until the seawater stops entering the tank? Assume constant seawater surface. So it stops when the final head is 0 or when the seawater entering the tank is at the same level as the seawater surface. So the final head is 0, so we use this same formula here, except that we replace here square root of 4 by square root of 0. So 2 times 12 quantity square root of 5 minus 0. So that's the formula. So 2 times 12 quantity square root of 5 minus square root of 0 over 0.62 pi 0.05 square root of 19.62. So that would be 2,488 seconds.